Forward chaining and backward chaining are both inference techniques used in automated reasoning systems, such as expert systems and rule-based systems, to determine the truth value of a goal statement based on a set of known facts or rules. 1. Forward chaining. Forward chaining is a data-driven inference method where the system starts with the available data, known facts or initial conditions, and iteratively applies inference rules to derive new conclusions. It begins with the known facts and repeatedly applies inference rules whose premises match the available data until no new conclusions can be drawn. It continues this process until the goal statement is derived or until no further inferences can be made. Forward chaining is often used in systems where the goal is to reach a conclusion based on observed data, such as diagnosis systems in medicine. 2. Backward chaining. Backward chaining is a goal-driven inference method where the system starts with the goal statement and works backward, attempting to find a chain of reasoning that supports the goal. It begins with the goal statement and attempts to find inference rules whose conclusions match the goal. It then recursively applies inference rules backward from the goal, attempting to satisfy the premises of each rule until it reaches known facts or until it cannot proceed further. Backward chaining is often used in systems where the goal is to determine whether a specific goal statement can be derived from the available knowledge, such as in planning systems or expert systems where the goal is to diagnose a problem. In summary, forward chaining starts with known facts and iteratively derives new conclusions until the goal is reached, while backward chaining starts with the goal and works backward to find a chain of reasoning that supports the goal. Both techniques are used in different contexts depending on the problem requirements and the available knowledge. Let's consider a simple problem and solve it using both forward chaining and backward chaining inference techniques. Problem. Suppose we have the following knowledge base of rules and facts in a medical expert system. 1. If a patient has a fever and cough, they might have the flu. 2. If a patient has a runny nose and sore throat, they might have a cold. 3. John has a fever and cough. Using this knowledge base, we want to determine what illness John might have. Solution using forward chaining. 1. Start with the known facts. John has a fever and cough. 2. Apply Rule 1. Since John has a fever and cough, we infer that he might have the flu. 3. No further conclusions can be drawn. 4. The system stops, and we conclude that John might have the flu based on the available information. Solution using backward chaining. 1. Start with the goal. What illness does John have? 2. Look for rules whose conclusions match the goal. Rule 1. If a patient has a fever and cough, they might have the flu. 3. Apply Rule 1 backward. Since John has a fever and cough, he might have the flu. 4. No further conclusions can be drawn. 5. The system stops, and we conclude that John might have the flu based on the available information. Both forward chaining and backward chaining lead to the same conclusion: John might have the flu. However, they differ in their approach to reaching that conclusion. Forward chaining starts with known facts and derives conclusions, while backward chaining starts with the goal and works backward to find supporting evidence.